Okay, lesson 5-1. So starting chapter 5 today, we're going to be talking about operations with functions. So the main things we're going to look at is that students should be able to perform arithmetic operations with functions, and then you should be able to apply those arithmetic operations with functions. So what we're saying is we're going to have at least two functions, and we're going to be adding, subtracting, multiplying, or dividing them. So addition, this is a notation. So you have in parentheses f plus g, close the parenthesis, and a new parenthesis of x. That means the same thing as taking f of x plus g of x. So you'd take your f function and add it to g. F minus g of x is taking an f of x minus a g of x. When it's a solid dot like this means to multiply. F times g of x is the same as f of x times g of x. F divided by g of x is the same as f of x divided by g of x. Now when you divide, you're going to have a special case here. Your denominator, so whatever g of x is, cannot equal 0. So you're probably going to have like a domain value that's not defined in the domain. So you'll see that as we get going here. So what Alex is going to give you, or what your homework is going to give you here, it's going to have you get two functions. So right here it says, suppose that the functions g and h are defined for all real numbers x as follows. G of x is equal to x plus 3, h of x is equal to 4x plus 1. And it wants us to find the expressions for g times h of x, g plus h of x, and evaluate what the value is when you have g minus h of 3. So you'll see that all of those are listed: g times h of x, g plus h of x, g minus h of 3. So if we start with g times h of x, this is going to be the same as g of x times h of x. Okay, so what we're going to do, g of x is x plus 3. So in the place of g of x right here, I'm going to put x plus 3. And then we have h of x is 4x plus 1. So in the place of h of x, I'm going to put 4x plus 1. Okay, so these two binomials are going to get multiplied together. So we did that last chapter in chapter 4 a little bit, where you're going to multiply your x terms together, multiply your number terms. It might have actually been chapter 3 or 4 we did this. So you're going to take the first term, multiply by the first term. So x times 4x is a 4x squared. Then we take x times a 1, and you get 1x. We're going to take 3 times 4x, and we get 12x. And then we're going to take 3 times 1 and get 3. When you go and simplify this, combine your like terms, which are the two middle terms, you're going to get 4x squared plus 13x plus 3. This is what this is what g of x times h of x is equal to. Okay, so this right here would be your answer. Now remember that you can do it this way: distributive property, make sure every term in the first gets multiplied by every term in the second, or you could make a little box and do like the 2 by 2 box and do your multiplication that way. Okay. The next one, we want g plus h of x. So this is going to be taking g of x and adding it to h of x. Again, g of x is going to be an x plus 3. And h of x is going to be 4x plus 1. Now again, I just substitute that in. And when we're adding, remember you just have to combine your like terms. So we're going to take x plus 4x. 4 plus 1 is 5, so you get 5x. And then we're going to take 3 plus 1. 3 plus 1 is 4. So this simplifies to be 5x plus 4. Okay. Finally, we have g minus h of 3. So there are two different options. You could first figure out what g of 3 is and what h of 3 is, and then subtract those. Or you could subtract the functions just like we did here, and then after you've simplified it to something like this, you can substitute this number in. I'll do it both ways on this, I'll do it both ways throughout the notes. So this first example, what I'm going to do is I'm going to find g, let me do it this way. So this is going to equal g of 3 minus h of 3. So what I'm going to do kind of off to the side over here is I'm going to find g of 3, and I'm going to find h of 3, and then I'm going to plug those numbers that I get in for these functions here. So g of 3, we've been doing this since chapter 1. You're going to take this 3 and substitute it in for x in this function right here. So I'm going to have a 3 plus a 3. And again, that's because the function was x plus 3. And so what I'm doing is I'm taking that 3 and I'm substituting it in for x right there. So 3 plus 3 is 6. So g of 3 is 6. Then I'll do the same thing with h. So h started out as 4x plus 1, and I'm substituting 3 in for x. 4 times 3 is 12. 12 plus 1 is 13. So again, you took the 3 and you substituted it in to the function that they gave us. So now what you're going to do is if we want to take g of 3, that's going to be this number, minus h of 3, which is this number right here, we're going to end up with a 6 minus a 13. And if I take 6 minus 13, I'm going to get a negative 7 as my answer. So you'll notice this is the only one that gives you just a numerical answer because these ones left it in terms of x. So your answer should still be in terms of x. Okay. Okay. So if you turn to the next page, we're going to do something similar. It says, suppose that the functions r and s are defined for all real numbers x as follows. So r of x is equal to an x squared, s of x is equal to a 4x cubed. And it wants us to find r plus s of x, r minus s of x, and r times s of negative 1. So remember, if you have r plus s of x, that's the same as taking r of x plus s of x. And I can find those up here. So r of x is going to be an x squared. S of x is going to be a 4x cubed. So r of x is x squared plus s of x, which is 4x cubed. Now, this specific problem here, these are not like terms, okay? An x squared cannot combine with an x cubed. You're not going to have anything that can combine, so this is as simple as it gets. This would just be your answer here. Similarly, if we go r minus s of x, that's the same as r of x minus s of x. And if we start with an x squared again, and we subtract a 4x cubed, again, we've substituted everything in. This specific one doesn't get any simpler because these are not like terms. So we would just leave our final answer like this. Keep in mind, it's not always going to be like this. Sometimes you might have some like terms, so make sure you're looking to see if there's anything that could combine. It just so happens that on both of these, nothing can combine. So now the last one, r times s of negative 1. So like I did on the last page, the last example, I found each of those evaluated for 3 separately, and then I just subtracted what those numbers were. What I'm going to do this time is I'm going to take the 2 functions, and I'm going to find r of x times s of x first, and then I'm going to plug in the -1 once I have that part right here simplified. So my r of x is an x squared times my s of x, which is a 4x cubed. If I multiply those together, 4 times 1 is 4, because remember there's like a 1 right there we don't see. 4 times 1 is 4. X squared times x cubed. You're going to add the exponents when it's the same base getting multiplied. 2 plus 3 is 5. So this is what r times s of x is equal to. Maybe I'll just write that back over here. So r times s of x is equal to 4x to the 5th. And if I'm looking for r times s of -1, what that means is I'm just going to put -1 in for that x. So if I take 4 times and then -1 in parentheses to the 5th power, I can type that right in my calculator. I'm going to get that it evaluates to a -4. So r times s of -1 would be equal to -4. Okay, so that's one option, is to just do it in terms of x first, simplify it to here, and then substitute whatever that number is. The other way was to put the numbers into the functions right away, and then just take those numbers and do whatever the operation is. So you decide what you want to do. Either way is going to work. Okay, so example number 2. So we've kind of covered the addition, the subtraction, the multiplication. Now what we're going to have to look at is the quotients. So looking at division. So it says, suppose that the functions h and g are defined as follows. We have h of x, which is a 1 plus x times a -1 plus x. And then we have a g of x, which is a 7 minus 2x. And it wants to know, what is h divided by g of 3? So it will also ask you, find all values that are not in the domain of h divided by g. If there's more than one value, separate them with commas. So the first thing I'm going to do, and you can just do it up here if you want, is I'm going to take h divided by g of x. So I'm going to just look at what the function is. If I stack these on top of each other, so put h of x on the top over the g of x, okay? So I'm going to start with that. H of x is a 1 plus x times a -1 plus x, and g of x is a 7 minus 2x. Okay, so if I don't have anything in for x, just taking the functions they gave me, h of x on the top, we're going to just leave it in its factored form, g of x on the bottom, again, just as it's given, this is what h divided by g of x looks like. Now, this is going to help us answer this part of it. It says find all values that are not in the domain. So if there's more than one value, separate them with commas. If you remember, which you may not, up at this chart here, it said that when you have the division statement, the bottom part of it cannot equal 0. So what we need to do is we need to figure out, is there a value, specifically an x value, a domain value, that would cause this denominator to become a 0. So all you have to do, if you just take the 7 minus 2x, I set it equal to 0. If you want to remember that it's not included, you could say does not equal 0. Okay, so 7 minus 2x cannot equal 0. So what I'm going to do is solve this. I'm going to subtract 7 I get negative 2x cannot equal negative 7. I divide by negative 2. X cannot equal a 7 over 2 then. So that is our value that is not in the domain, okay? And we got that by putting these in terms of x, dividing them, taking your denominator, setting it equal to 0. Again, you're looking for it where it's not equal to 0. You don't want it to equal 0. This would be the number that would not be in the domain then. So then, if we just do this part, h divided by g of 3, we're going to take this function. Everywhere that there is an x, we're going to put a 3. So I'm going to have a 1 plus 3, negative 1 plus 3, and on the bottom I have a 7 minus 2 times 3. So on the top, 1 plus 3 is 4. 3 plus negative 1 is going to be a 2. 2 times 3 is 6 on the bottom, so 7 minus 6 is a 1. 8 divided by 1 is just an 8. So h divided by g of 3 is an 8. And then the domain value, again, is it cannot equal a 7/2. Okay. The last one then, letter B that we have, says suppose functions h and g are defined as follows. So h of x is equal to x minus 5, g of x is equal to x minus 6, and x minus 1, or times x minus 1, okay? One thing I should also mention, on all of these examples, the order that they were given, so h of x, g of x, r of x, s of x, these were always written in the same order that they were given here. That may not always be true when you get to your assignment, so make sure you look to see. It's possible that they could put g over h, and then you would just put this function on the top. So just make sure you're being very careful as you're working through those, okay? But anyways, back to this question. So we have h of x, we have g of x, and again, we're finding what that evaluates to when our x value is negative 6. So I'm going to start by just finding h of x over g of x again, because that's going to help me figure out what values should not be in the domain. So h of x is an x minus 5, and g of x is an x minus 6 times an x minus 1. So now this one still, remember, we do not want our domain to be equal to 0. So we have x minus 6 times x minus 1. We do not want equal to 0. Hopefully this looks familiar. We just spent all of last chapter, or not all, but a lot of last chapter. These are its factored form. If we set these factors equal to the 0 or not equal to the 0, that's going to get our values that are not going to be defined. Because again, you do not want these to equal 0. So you can say that x minus 6 cannot equal 0. X minus 1 cannot equal 0, because that would cause the whole denominator to become 0. So let's see what these values give us. We add that 6 over. So we don't have a domain value of 6. And we do not have a domain value of 1. Those are the domain values that we do not have. So you would just type in 6, comma 1. That's where it would be undefined, okay? Now, we're going to substitute in that negative 6. So h of negative 6 over g of negative 6. So I have a negative 6 minus 5, and on the bottom I have negative 6 minus 6 times a negative 6 minus 1. Okay, so again, I took this negative 6 and I plugged it in for all those x's. Negative 6 minus 5 on the top would give you a negative 11. On the bottom, negative 6 minus 6 would be a negative 12. Negative 6 minus 1 is a negative 7. And so if you take a negative 12 times a negative 7 in your calculator, that would give us an 84. And so this comes out to be an evaluation of negative 11 over 84. Okay. Okay, so take your time on the assignment. Just make sure you're paying attention to what function it wants at the start. And you should be okay. I mean, look at the examples. If you get stuck, help each other out. Okay, thank you so much. Have a good day. Bye.